Welcome back. Let's do question 2. Two blocks, A of mass 4 kg and B of mass 9 kg, are connected by a light inextensible string. The blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. A constant force, F, acting parallel to the plane, is applied to block B, as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second squared. State Newton's second law of motion in words, right? We must know our definitions. What does the Newton's second law of motion say? Right? When a resultant force acts on an object, the object will accelerate in the direction of the force. But the main part that we must make sure that you write is the acceleration is directly proportional to the resultant force. Or you can say the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So acceleration is directly proportional to what? To the net force and inversely proportional to the mass of the object. Okay, that's the definition there, and then you get your 2 marks. The kinetic frictional force acting on block A and B are 5,88 newtons and 13,23 newtons respectively, meaning that this one's for A and then this one for B. Draw a labeled free body diagram showing all the forces acting on block A. And then we have 4 marks. Alright, 4 marks, it means what? It means we have to have 4 forces here. So we have our dot there for the object, and then which forces are acting on this object. Obviously, we'll have the normal force, which is going to be perpendicular to the inclined plane there. So we have the normal force. All right, that's the normal force. And then we have the tension on the string. So we have the tensional force there. That's tension. Okay, we have our 2 marks. What else do we have? We have the frictional force. We have the frictional force. Right, and then one more force that we need, the weight. Okay, the weight of the object. These are the forces that we have to indicate. Question 2.3. Calculate the magnitude of the tension force in the string. Right, which block should we use here? We can use A. Can we use B? B will be a bit difficult because we don't have the force here and then don't have the tension here on the string, so it will be a bit difficult to use B. Let's use A. Right, let's use A. We say that we have the tension, okay, and then we have the normal force, and then we have the frictional force. And then what else do we have? We have the weight, and then the weight has what? Is 2 components. One component, this is the weight, it is 2 components. The one which is parallel to the plane, to the inclined plane, and then the other one which is perpendicular to the inclined plane. So we have the component which is parallel to the inclined plane. For weight parallel to the inclined plane, we say mg sine theta. This is our theta that we're referring to, because when we draw our weight like this, and then this is perpendicular to the inclined plane, then this angle will be just the same as this. So like this is going to be 35 also. Right, so for the weight component which is parallel to the inclined plane, we use mg sine theta, and then for the one that is perpendicular to the inclined plane, we use mg cos theta. Remember that. Let's find our net force. So F net is equal to ma, isn't it? And then F net is what? Let's take up the incline as positive. Let's take up the incline as positive. So our T there is going to be positive. And then our F, this is 0, perpendicular to the inclined plane, so it's 0, we don't count that. And then F, the opposite direction, so negative F. And then the parallel component of weight is also negative that, okay? All right, and then this is equal to ma. Okay, this one is what? This one will be T minus F minus mg sine theta, okay, is equal to ma. The mass is 4 and then the acceleration is 2 meters per second squared, so it's going to be 4 times 2, right? And then let's substitute what we have. So t, and then minus 5,88. Okay, we say this one is frictional force for A, and then minus 4 for M, and then G there is 9,8, and then sine 35 degrees is equal to 8, right? So the best thing here is to find this, but be careful here. So if you're finding this part, you want to put this in the calculator, you have to put it with this negative 5,8, okay? Otherwise, the best thing will be transpose all this, put it on the right, okay? So it becomes t is equal to 8, and then plus 5,88 plus 4 times 9,8, and then sine 35 degrees. You just do that, and then you put this whole thing in the calculator. All right, what are you going to get? You'll get that t is equal to 36,36 newtons. That is to 2 decimal places, but before we round it off, it was actually t is equal to 36,3641963. Now because this 4 is less than 5, so the 6 does not change, and then we get this. All right, we could have taken down the incline as positive. We can also do that, it's fine. If you take down the incline as positive, then t there becomes negative t, so it becomes negative t, and then the friction becomes plus there, positive, and then even the parallel component of the weight is going to be plus, then mg sine theta, like that, and then it's equal to ma, and then m is 4, and then acceleration, now we're taking down as what, as positive, but you said here the blocks accelerate up the plane, so it means acceleration should be negative. Now you see that we can also do that, then become negative t, and then plus 5,88 plus 4, that's the mass there, that's the m, and then 9,8, then sine 35 is equal to negative 8. See that? And then we can transpose everything, move all this to the right, so it becomes negative t is equal to, and then you can have negative 8 minus 5,88 minus 4, then 9,8 sine 35, and then you can put this whole thing in the calculator. You'll get your negative t is equal to negative 36,36 newtons, and then t is equal to 36,36 newtons, like that. 232, we want to find the force here, so we're going to use block B. Let's have the forces acting on B. We have the force, let's take upwards as positive. All right, so we have the force there, and then we're going to have what here, tension, isn't it? We're going to have tension, and then also we have friction, and then on top of that we have the component of the weight that is parallel to the inclined plane. So we'll have the component of the weight that is parallel to the inclined plane, like that. Okay, so we're taking upwards as positive, so it's going to be, we have our F net is equal to MA, right? F net is going to be F, and then minus T minus F, and then minus the component of weight that is parallel to the inclined plane, so it's going to be like this, and then is equal to MA, right? Let's substitute what we have. F is equal to F minus, we managed to get T. Remember, in this question we wanted to find T, we said it's 36,36, then minus the friction for B is 13,23, right? And then the component of weight parallel to the inclined plane will be mg, which is 9, mg 9,8, then sine 35, which is equal to ma, so it's going to be 9 times 2, like that. Okay, and then what you can do, again, I would advise you to transpose this, but if you want to find the value of this, you have to start from negative 36, put from negative 36 into your calculator up to sine 35 there. But if you transpose, you can say F is equal to, we have 9 times 2, then it's going to be plus 36,36 then plus 13,23, and then plus 9 times 9,8, then sine 35, and then put this whole thing in the calculator. You will get that your force is equal to 118,18 newtons, rounded off to 2 decimal places. Right, we could have taken downwards as what? As positive. It's still fine. But if you take downwards as positive, this becomes negative f. So remember, f net is equal to ma, and then our f net there is going to be negative f, and then plus t, then plus friction, plus the weight component parallel to the incline is equal to ma, right? Then it's going to be negative f, then plus 36,36. We found our t in question 231, and then plus the friction, which is 13,23, and then plus mg, which is 9, and then 9,8, then sine 35 degrees, and then is equal to 9, and then acceleration now is going to be negative because it's going down, negative 2, like that. Okay, then we can transpose everything. Negative f is equal to 9, and then negative 2 minus 36,36 minus 13,23, then minus 9 times 9,8, then times sine 35 degrees, and get negative f is equal to negative 118,18 newtons. Then f is equal to 118,18 newtons, like that. Okay. Question 2.4. The angle that the plane makes with the horizontal is now decreased. How will this change the kinetic frictional force? How will this change the kinetic frictional force acting on block A? Choose increases, decreases, or remains the same. Right. So now we have to look at the relationship between the frictional force and the normal force. Okay. Frictional force will be, we have the coefficient of kinetic friction, and then times the normal force. So here there is direct proportion. When the normal force increases, the frictional force will increase. This is the normal force, right? And then we have this angle here, which is what? Which is, let's say, theta. Okay, right? This is the weight. Now this is the component of weight that is perpendicular to the inclined plane. This component perpendicular to the inclined plane is equal to the normal force. Right, we want to see now if this angle is decreased, what will happen to this perpendicular component. Okay, right, if the angle is decreased, what happens to the perpendicular component? Remember, say that the perpendicular component of weight is equal to mg cos theta. Remember, I said that. Now I want you to observe something. Let's just pick two random angles. Let's say maybe theta is equal to 20 degrees, and then theta is equal to maybe 10 degrees. Right, I want to compare this. Let's say cos 20 degrees. What is cos 20 degrees? It's like 0,9396, goes on like that. What about cos 10? 0,98, right? 48, goes on like that. So do you see that if the angle decreases, cos theta increases? Do you see that? If the angle decreases, cos theta increases. Like here we have cos 20, which is this, and then we have cos 10, which is this. Okay, so now meaning what? If the angle is decreased, then the component of weight perpendicular to the inclined plane will increase, meaning that the normal force increases. Because if this increases, then the normal force increases, isn't it? So now if the normal force increases, then the frictional force increases, because these two are directly proportional. This is a constant, right? When the normal force increases, then the frictional force increases. Okay, so now I've covered both 241 and 242 here. So 241, we're saying that increases. That's the answer for 241. Then 242, okay, right, as the angle decreases, normal force increases, thereby increasing the frictional force.